are going to explore the Chinese Postman problem, an important concept in graph theory.
Imagine a postman who needs to deliver a mail across a town, ensuring that every street is covered at least once while minimizing extra travel. The Chinese postman problem (CPP) is a graph theory problem that focuses on finding the shortest route for a postman to deliver a mail for a garbage collector to cover all the streets in a neighborhood. The goal is to find the minimum distance that needs to be traveled so that every edge repeating a street in the graph is travels at least once, and the postman ends at the same starting point if the town's road network forms an Eulerian circuit. The task is easy. He can start at end and end at the same location without repeating any road. But if not, then our postman is in a trouble, and we have to help our postman.
A graph is called Eulerian if all vertices have an even degree vertex. As I told, this is a perfect map that our postman can travel and comes to the starting point without any issue. So this is an Eulerian graph. You can find circuit that that covers every edge exactly once and returns to the starting point. Look at the map carefully. Here every edge has an even number of streets connected to it. This graph has a Eulerian circuit, which means Mr. Lee can start and finish at the same place while covering every road exactly once. For example, if Mr. Lee starts this delivery work from the intersection A, he can end this journey also in the same intersection A. He can travel from A to B to C to B to D to C to A to F to D to A, C. Finally, he can come to his starting point. That means we can see Eulerian circuit clearly here.
Semi-Eulerian graph. If exactly two vertices have an odd degree, the graph has an Eulerian path. A path covering each edge once but not necessarily returning to the starting point. That is what we call as semi-Eulerian graph. Semi-Eulerian graph. Look at this map that our postman got. He have 5 intersections: A, B, C, D and E. At the intersection A, there are 3 streets: A to B, A to C, A to D. That the degree of A equal 3. The degree is number of edges connected to a node. So there is 3 edges connected to the intersection point A. At intersection B, there are 4 streets: B to A, B to C, B to D, B to E. Degree of 4. There are 4 streets. That means it is even. At intersection C, there are 4 streets: C to A, C to B, C to D, C to E. Degree of C is 4. At intersection D, there are 3 streets: D to A, D to B, D to C. Degree of D is 3. At intersection E, there are 3 streets: E to B, E to C, and there are also an even number. Degree of E is 2. So look at the 2 nodes, 2 intersections, A and D. Those 2 intersections have an odd degree. Those 2 only have odd degree. Since the graph is semi-Eulerian because there are only 2 odd degree vertices. Only 2. So others are even. So only 2 have there. So that is called as odd degree vertices. So that is finally we told that graph as a semi-Eulerian graph. To complete his delivery route efficiently, the postman must start at one of the odd degree intersection and end at the other while covering the every road exactly once. That means this graph contains Eulerian path as we discussed earlier. So, if Mr. Lee chooses A as its starting point and plans his route carefully, ensuring that each street is used only once, he follows a structured path reaching D at the end. A2. So we can see for an example for an Eulerian path in this graph. We can start from A and end from D. So for an example, A to C, C to E, E to B, B to C, and C to D, and D to B, and B to A, and A to D. So we have finished it at another odd degree word is D. This ensures that every edge is covered exactly once. Non-Eulerian graph. If more than two vertices have an odd degree, it is not Eulerian at all, and you will have to add extra edges to make it Eulerian, and that type of graph called non-Eulerian graph. This graph do not contain neither Eulerian circuit nor Eulerian path. Handling that issue in the Chinese postman problem, the postman must duplicate some edges to make all the vertex degrees even. The strategy is find pairs of odd degree vertices and calculate the shortest path between them. Duplicate the minimum number of edges to make the graph Eulerian. In this graph, we can take an example as pair of odd degree vertices B, A to B, C to D, etc. and determine the minimum additional edges to add. One position solution, duplicate edges A and B and C, D. This way, the postman can cover all streets and return to the starting point without missing any. Finally, Mr. Lee found the best route, and today Eulerian graph theory is used in real-world applications also. Understanding Eulerian paths and circuits allows us to solve problems in logistics, urban planning, and even DNA sequencing. So finally we are talking about some of the applications. We already have discussed some. So here's some of the another application of CPP, postal delivery routes. As we have discussed in this lesson, the postman needs to deliver mail to all the houses in a neighborhood and minimize the total travel distance. So the garbage collection routes, a garbage truck needs to collect trash from all streets in a city with a minimal travel time. So another example, street cleaning. In cities where cleaning must cover every street, CPP can help them to optimize the route. And with that, our DNS, data structures and algorithm videos playlist has come to an end. Thank you so much for watching us. Stay tuned and subscribe us for another lesson series. Bye bye.